Hello, my name is Dr. Abrahamian, and in this channel, I go over problem-solving strategies mainly in math competitions. This is a video on problem 6 from the 2025 International Math Competition for University Students. This is a competition that was held a few days ago. Let f from positive real numbers to real numbers be a continuously differentiable function, and let b greater than a greater than 0 be real numbers such that f of a and f of b are k. Prove that there exists a point psi between a and b such that f of psi minus psi f prime of psi is equal to k. Okay, so this looks like Rolle's theorem or the mean value theorem. So what is the mean value theorem? Mean value theorem tells us that if you take a function that is differentiable, then you can find, so let's say your function from AB to R is differentiable and continuous over the closed interval, then there is some c that f prime of c is equal to f of b minus f of a over b minus a. So this looks very similar to the mean value theorem. The difference though is on the left side, we don't have derivative of one function. We have f of psi and also minus psi f prime of psi. So this is not derivative of just one function. So I was hoping to that I can turn this one into derivative of one thing. Well, when I look at this expression, I can see that this is kind of like the quotient rule formula. So if you look at the derivative of f of x over x, and by the way, since they told us that the domain is all positive numbers, we don't have 0 at the bottom. So this was another indication that I'm probably on the right track. So we take the derivative of numerator times the denominator minus derivative of denominator times numerator. And you see the relation between this and that? They're almost the exact same thing with the negative sign. So I decided to apply the mean value theorem to this function and see what we can get. So we have some c between a and b such that derivative of f of x over x at x equals c is equal to f of b over b minus f of a over a over b minus a. So let's see what we get on that side. So on the left side, we get derivative of this, which is f prime of c times c minus 1 times f of c over c squared is equal to, and on the right side, we get k over b minus k over a over b minus a. So we're going to simplify this. We get ab at the bottom, and we get negative k on top. So this isn't exactly what we wanted, because we wanted to show this c gives us this expression is equal to k. So I decided that I have to modify my idea. So still, the idea that this is the derivative of f of x over x seems to be a good idea, but I'm going to modify this. So they told us that this is equal to negative k. This is a slightly different from what we started with. What we started with was f of psi minus psi f prime of psi, and this is negative of that. So this is what we want to show. So I'm going to divide this one by c squared to get the derivative of the quotient, and I'm going to divide this side by c squared as well. So this is the same as derivative of f of x over x at x equals c is equal to minus k over c squared. But I do notice that this side is also a derivative of k over x at x equals c, because the derivative of k over x is negative k over x squared. So this looks like I should be able to solve the problem. So I'm going to take the derivatives on the right side, put it on the left. So this would be f of x over x minus k over x at x equals c equals 0. So now let's apply the mean value theorem or intermediate value theorem to this function. So consider this function, f of x minus k over x. So in this function, we can say this function from 0 from positive real numbers to real numbers is a differentiable function. So now if you look at this function, there is a c between a and b that the derivative of this function f of x minus k over x at x equals c is equal to f of b minus k over b minus f of a minus k over a, all of that divided by b minus a. Okay, so let's see what we get. On the left side, we are going to use the quotient rule. So derivative of numerator, so that's f prime of c times denominator minus derivative of denominator times numerator is equal to, and on the right side, and by the way, this is minus k. This is equal to the right side, f of b and k are the same, f of a and k are also the same, so actually the right side is 0. So this means f prime of c times c minus f of c plus k is equal to 0. We're going to move this portion to the other side, so we get f of c minus c f prime of c equals k. And if we look at what we wanted to prove, it was f of psi minus psi f prime of psi. We got exactly what we wanted. And that brings me to the end of this video. So I will see you in the next video.